Welcome back, folks. Emo is going to talk all about Debian Live for us now.
Thanks very much. Yeah, so the topic is Debian Live. General outline so that you're not surprised about the crazy things I will tell during the presentation. We'll start with a bit of an intro on live distros, what they are, a bit of history. Not a very long section. Then I'll talk about Debian Live specifically, so what Debian Live is and how it works a bit in general, and then also more in detail under the hood. And then we'll conclude with a few case studies, with a few interesting, I hope, examples of how Debian Live is used or can be used. First of all, what are live distros? I think pretty much everyone knows, but just, as a general overview. It's a distribution that runs directly from some sort of external storage, so not your hard drive. For example, if you're on a laptop, probably not the hard drive installed in the laptop, but rather a USB stick, probably these days, maybe a secure digital SD card. And a few years ago, CDs or DVDs were the default sort of storage you would use for this. Nowadays, laptops don't have DVD drives anymore. It's increasingly harder to get a computer with a DVD drive, so probably USB sticks. The main idea is that not only you don't have to install anything on the hard drive, the machine you're using could also not have any hard drive at all, which is one of the use cases we will see later on. Why would you want to use a distro like this? Maybe because you want to try Fedora. Haha, no. Or for system recovery if something breaks, or if you want to use a machine for temporary usage, and many other examples we'll see later. I don't know if this is readable at all, but this is a CD for the people who have never seen a CD before. And it's an interesting CD, I think, because it's the first live distro, the first Linux live distro, which was called Yggdrasil. And it came out in '92. This CD here was from 1993. So definitely very, very early days before pretty much most of the distros that we know. And it was live. So the idea is that you could insert this into your computer, boot, and get a Linux system with whatever you can expect, mostly like a very old kernel. And the motto of the company, there was a company that made this distro, was plug and play Linux and free software for the rest of us, is what they were saying. Those, of course, were the very, very early days. And then what really popularized the concept of live distros was Knoppix or Phoenix, which many surely know. Both of them were based on Debian, general purpose, so they didn't have any specific use case in mind. It was mostly, a distro that works and boots, and then you get a graphical system. Lots of people were using them for system recovery, at least, as working as a sysadmin, I know that lots of people had a Knoppix CD somewhere that they could use to fix Linux systems that got screwed up when running Lilo, or Windows machines that had viruses and those kind of things. Debian Live, which is the topic of this presentation, came out in 2006, and Fedora and OpenSUSE also had versions of their distros, live versions in 2007, starting from 2007. Other than the general purpose ones, there are a few very popular live distros that go for a specific use case. Tails is perhaps one of the most well-known. The focus is privacy and anonymity. It comes with Tor pre-installed, and by virtue of being a live distro, of course, it's good in terms of privacy because you just don't store anything on the disk. So if some police force or whoever else gets their hands on your machine, you're not that concerned. Kali Linux was, I don't know if it's still actually really in use, but was quite popular for security professionals doing forensics and penetration testing. An interesting one I found is Puppy Linux, which focuses on having a very small footprint, so it runs on older hardware, but it's also very easy to use. So essentially, putting back to use old machines that may otherwise just get dust. Another distro with an impossible name to pronounce is Grml, which is targeting sysadmins, and it comes with Fluxbox, I think, by default, and it has a ton of very cool software pre-installed for data recovery, system repair, network testing, and whatnot. Okay, so that was the section about the generalities of live distros. Let's see about Debian Live more specifically. What is Debian Live? Well, as you can probably imagine, it's a live distro. The peculiarity is that the images are actually provided by the Debian project. So these are images that are built on Debian systems officially. And they are also made of only unchanged Debian packages. So there is no random stuff that someone built and put into the image. It's only packages in the Debian archive that make the live system. And yeah, so you get all the guarantees of using Debian packages in terms of software freedom, in terms of quality and all that. There are different ISOs for all possible desktop environment. Well, I shouldn't say this, of course, but yeah, most desktop environments. But also, live build, other than being pre-built live images, it's also a framework that allows you to fairly easily create custom live images. That's it. All you need to know is in that slide if you want to create your own live image, or most of what you need to know. The package that allows you to build an ISO is called a live build. And then you type lbconfig in a temporary directory. This is going to create some directory structure. So don't just run it in your home or it will pollute all of it. And then you can specify the list of packages you want to install into a file under config package lists. The name doesn't really matter as long as it ends with .list.truth. In this example, I've chosen live task GNOME, which pulls in a lot of stuff, GNOME, LibreOffice, a lot of things, multiple language packs, and so forth. You can, if you want, of course, be much more specific and only go for a selection of packages that you care about. And then you type lbbuild, and after a few minutes, depending on your hardware, but about 15, 20 minutes, if you just build the whole gigantic live task GNOME, you get your ISO. Other than choosing the list of packages, you can also specify, custom config files that you may want to have. Nobody is happy without a custom message of the day, of course. But you can also run scripts. So the idea is that the live build framework will create a truth and then install packages in there and potentially run scripts in there. So if you want to really fine-tune things, you can also specify hooks, which are just scripts that will run at the end or before of the stage where the truth is being prepared. So you can, for example, just remove all documentation if you don't care about that. And yeah, so run arbitrary commands towards the end, for example, of the build process. Oh, if you want to stop me at any point, please do. There's also a manual. There's documentation, crazily enough, which is maybe not always up to date, but it is good. And if you want to customize things, I recommend to take a look. Of course, if you just want to use the ISO, you don't need to read any you shouldn't need to read any documentation. But if you want to customize things, you can do that, and the live manual should be good enough. If it's not, please help in fixing it. Where do you get live images? Well, given that this is all very official and very Debian, you get the images from the Debian website. We do have images for AMD 64, obviously, and ARM 64 is coming as well. With Roland here in the first row, who's the maintainer of Debian Live, we've been doing a bit of work at the Hamburg MiniDebConf on getting the live images built for ARM 64. The main issue, which is not particularly, it's not very much of a crazy issue, is that the machine building the images is x86. It's called Casulana. And given that, as I mentioned, building the ISO has a step where you create a truth and you install packages into that truth, if you try to do that for a cross build, so to say, so if you want to build an ARM image on an x86 machine, then somehow you have to do this with QEMU user static or similar, which takes forever. So we have built an image. It took very long. So there is one official image that is available, and we're trying to figure out solutions. Probably finding a ARM64 machine where the images can be built is the easiest solution. I think we will go for that approach. The work done in order to get the first ARM64 image to build was also not crazy stuff. For example, we found that installing the AMD64 version of Grub was a bad idea. And we also wanted to ensure cross-build reproducibility, so to make sure that if I make a ARM64 image on my ARM laptop, and then Roland makes another image on his x86 machine, we want to make sure that the two ISOs are bit by bit identical. That took a little bit of work. And then other than that, we've set up automated testing on OpenQA Debian.net. So on OpenQA, also with the help of Phil, which also in Hamburg helped a lot with this, we ended up setting up one job that builds the test that ARM64 ISO. And the way we did that was by taking the x86 tests, unmodified, and just apply them to the ISO, to the ARM ISO, which is a good test in itself, just to verify that the two architectures are doing the same stuff with GNOME and so on. The only ISO we have built is available at that URL for ARM64, and again, hopefully we will build them regularly on a weekly basis for ARM as well. Okay, now some more details about the implementation of Debian Live. These are the main components of the whole system. Unsurprisingly, there is a Linux kernel, which is the actual Debian kernel. So if you have a server running Bookworm, the very same kernel, the very same VM Linux is also on the live ISO. What changes is the sort of initramfs you get. The initramfs of a live system has a few scripts that come from a package called liveboot, again in the Debian archive. And then what the image does after that step of creating the truth that I mentioned before is to create a squashfs out of that. Squashfs is a compressed read-only file system. It is actually the system that you will run on the machine where Debian Live runs. However, it's not great to have a read-only file system. You probably need to write something at some point. And to do that, the Debian Live creates an overlay fs, which allows to write on top of the squashfs in memory. Once that is set up, so once you have a root file system which is temporarily writable, you then need to probably run something, and what that something is a systemd unit. Liveconfig.service is the actual name of the unit, which comes from the package liveconfig and starts things up. For example, it makes sure that you have that your user is part of all the important groups, like floppy, for example, and then that GDM starts and all those sort of things. Quick recap of our regular system boots, so not necessarily a live system, just in general, a modern machine, a machine with a UEFI firmware. There's a EFI removable media path, which is used by default, or in case you don't have any NVRAM variable set with bootloaders. And it's a well-known path. This is the path for ARM systems. It's very similar for x86. And that's an EFI application, probably Grub or something like this. Grub then reads a config file. This config file has one statement for the Linux kernel with the path to the image, probably a root device and other things. And finally, initram disk. Then the kernel boots, unpacks the initram disk, and calls init from the initram disk itself. Init does a lot of things, including mounting root, and then it calls bin init, which nowadays is a symlink to systemd. What are the differences between that and what Debian Live does? Not very much. Mostly there's a kernel argument called boot, boot equals live. And what initram disks do, in that case, when there is a boot parameter, they execute /script / the value of boot, in this case /script / live. And that calls a function which is in the specified in the live boot package. And this function finds out where the squashfs is on the media, let's say the USB stick. And then there's another function which sets up the unionfs. Not crazy stuff, the name kind of gives it away. Unionfs is a combination of your squashfs, in-memory tempfs. It's an overlay that then is mounted under /root. And then at the end of the whole dance, init calls run init /root, which basically does a pivot. So your new root, as in / partition, becomes the /root. And then the system is ready to go. Now, if something goes wrong, you can debug things. You shouldn't, but in case of issues, you can. There's a debug command line argument that you can pass to the kernel. And if you do that, so if you add debug at the end or wherever on the kernel command line arguments, you will end up with a file under run init ramfs. And then you can inspect that file and see what broke. If you pass debug equals anything, this changes. So you do get out debug, but not in that file. You get it to standard output, well, to the console instead. Important to know. Init ramfs tools, the man page has a lot of documentation and explanations about all the possible arguments. And there's also a file under varlog live boot.log, which is the output specific of the live boot script. So by looking at init ramfs debug and boot.log together, you should get a good idea of what exploded in the early part of the boot process. And if anything went wrong after that, then you look at the systemd unit, which is what happens at the end of the initRD and once the squashfs is ready and once the rest of the boot process has finished. Okay. A few case studies, a few examples of why you may want to use in 2024 a live distro. The first one is what I'm doing now. This is a burner laptop. It's a machine that I don't normally use. And it's very, it's plasticky. It's a very old laptop, which I bought a long time ago, but it works. A definition I found online about what is a burner laptop is this. It's a device unconnected to your true identity and free from any trackable purchase history or personally identifiable information. But I like to think about a laptop that I'm not sad about if it's gone. I'm just a bit sorry for the stickers that I collected over time. And why would you want to use such a system in any situation where you're in a place with a lot of people? In this case, I trust you all, of course, but you never know. You could lose the laptop while traveling. Maybe you're attending a security conference about physical security, and you don't want your laptop to be used as a case study for that. Specifically, Debian Live, I think, is a good idea for a burner laptop because we all like Debian, and you get a system that has a ton of stuff already pre-installed, so you don't even really have to think about what you may want to get with you. You just have the system with a lot of stuff. What I normally use, and I suspect a lot of people in this room as well, is a terminal to SSH around, Firefox, and a PDF reader, so we can see the slides. I also have an external authentication device here, a YubiKey, which I always have with me, which is physically unconnected from the machine. And I have my SSH and GPG keys there. And also, the USB stick with the OS is in my backpack now. So, this is a very clear mental model for me. I don't have anything really important even connected, so I'm happy about that. This is an old Chromebook, which would have otherwise, been thrown away because the updates from Google, you would get them only for 5 years on this specific machine. I bought it in 2017, so, system for security purposes without security updates would not be great. So you can install the core boot firmware on this one specifically and run whatever system you want. There's a kernel argument you can pass to the live system, which is 2 RAM. If you do, then the system will not run from the USB stick, but actually from memory only. So towards the end of the boot process, everything which is on the stick is copied in memory, and then you can put the stick somewhere else and the system works. Only slight problem with that idea is that this little stupid machine only has 4 gigabytes of RAM, and the default ISO is 3.2 gigabytes, so that makes it very, very big. So I did build a custom ISO for this purpose so that I don't actually have to fill the whole memory with the system itself. So if you want to use 2 RAM and if you have a machine with limited memory, it's perhaps a good idea to shrink the ISO. The default password is live. This is useful to know because, well, if you close the lid of the laptop and then you're prompted for the password and you don't know it, that's not great. We actually found that this is a bug, so part of the live service, well, the scripts that set up the system should actually disable the fact that you're prompted for a password, because the general use case is that you boot from the ISO and don't know much about the system at all, so you don't know the password, for example. We fixed that, so now it won't ask you for the password by default. If you want to build your own secure system, of course, you could choose a strong password and then tell GNOME or whatever system to prompt. The other use case has to do with DNSSEC. Now everyone says, what are you talking about? Very brief detour on DNSSEC, what it is about. Mostly the idea about DNS is that you want, for example, to know the IP address of a domain, and then you ask a server and you get a response. Of course, any sort of nefarious actor could just respond earlier and tell you something else. It would be good if we could validate the response and know that it comes from a trusted party. So, the idea was, let's just sign those responses and validate them on the client. The whole system is based on a concept of chain of trust, a little bit like the web of trust in the world of GPG, but in this case, you don't trust signatures by multiple people, but rather the signature from, whoever is the parent of a certain zone. This works great till you reach the root zone that has no parent, so now who are you going to trust at that point? The root zone is maintained by IANA, and we trust them because they have a ton of great security measures in place when generating keys and when using them. The Guardian called those keys the key to worldwide internet security. They are definitely very important. So what are these security measures that they have in place? You guessed it, they use Debian Live. What they're doing is they're doing so-called signing ceremonies, which are actual very long procedures. The last one that I've linked there took 7 hours and a half of people in the same room doing things. There are full videos if you really want to spend 7 hours and a half. Well, you probably don't want to watch it all. But yeah, so they're very public and highly audited procedures. They have scripts that they go through, and there are multiple people in the room from different countries and different organizations. Everyone checks that everything is done following the script, and then they write down, oh yeah, this step was done at 11:53 by da-da, and they sign things. One step of the ceremony is to double check that there is no hard drive physically into the laptop. And there is no hard drive, so they're using a live distro, and the DVDs were what they were using till last year. They had an external DVD reader, and they were using the DVD to boot the OS. And now they're using read-only SD cards instead. So SD cards with a physical switch, where you say, okay, now I want this to be read-only. And that's what they use. They use Debian Live, but they don't use live build. So essentially, they build a Debian system by using some scripts that you can find on that GitHub repo. The reason why they have a custom procedure is that they want to make sure that the ISOs are reproducible at any point in the future. So if they build the ISO for Ceremony 54 a few months ago, they want to make sure that somebody in 2030 could say, okay, I want the same ISO that they made that day. So just by passing the date, you manage to rebuild the same ISO. The procedure is based on snapshot-debian.org, so the packages are coming from there. And then, yeah, so at any point in the future, you can double-check that the ISO they used that day is the one you've built now. I don't know if this is readable, but this is part of the one of the steps where they double-check the checksum. So they verify that the SD card is properly inserted and all of that. And then they basically they use SHA-to-word list to generate a long list of words that can be spoken out loud with the based from the SHA-256 hash. And there's actually somebody reading everything out loud and somebody else that goes like, oh yeah, oh yeah, oh yeah. Okay, final use case that I wanted to present. Somebody here at ARM said, oh, cannot we use like live images to test servers? I thought, oh, that sounds like a great idea. The main concept is that you can network boot a live ISO, set up the environment with some config management, for example, Ansible, then run your benchmarks, collect results, reboot. Why would you use a live ISO to do something like this? First point is that it's very easy, as I hope I've shown before, to create a custom image with everything you need. And so basically, not only it's easy to create it, but it's also easy to make a repeatable image. And it's simple to guarantee that the image you've created and is running on server A is exactly the same image that is running on server B, which is good so that you know that you're not using different versions of important software. Also, you don't have to mess up the server hard drive, which is usually a good idea, especially if the machine is also used for other things, and then only temporarily it's depooled or it's not used for a while, and you want to run tests or benchmarks in that time frame, but then you also would like to still get the data back once you're done benchmarking things. Not messing up the bootloader of a server is also a good idea in general. I was thinking a bit about the commonalities between these sort of use cases, and I think two important ones are that, as mentioned before, you have a guarantee of the identity of the system. Of course, you could do this on any regular machine as well, but in this case, it's very easy because you have just one ISO, one file. The SHA of that image is sufficient to guarantee identity. It's very easy to revert changes. Changes are all temporary because they're in memory. I like this idea of the very simple and clear mental model. As I was mentioning before, 2 USB sticks in my pockets, nothing is on the machine. I like that idea. And it's also trivial to roll back to a known state. You just reboot and you're back. Configuration management also, till a certain degree, is simple. You can write a simple script that creates the ISO. So if you want something very custom and configured just for you, you can write a script of a few lines and get config management by using that script. I was recently at the All Systems Go conference in Berlin, which focuses on systemd, essentially. And a lot of talks were about these 3 topics for purposes of security. First one is immutable USR, so that nobody, no attacker logs in and messes up with your USR partition, and then you get persistent attacks that way. AB partitions to make sure that you can upgrade the system and then roll back to the previous state if something went wrong with the upgrade. It's a bit tricky to implement. You need 2 different partitions. You need some plumbing. You need, for example, Btrfs snapshots. Different ideas, but there is work to be done in order to get this. And additionally, a lot of TPM-related work to make sure that stuff is not modified. Live images give you pretty much all of this stuff for free. It's not really one-to-one comparable, but generally speaking, you get most of these benefits. USR is immutable because the media is not there, so you're not going to write my USR. If you want to upgrade to a new version of the OS, you can do it by writing an ISO on a different USB stick. So now media A is USB stick A, media B is USB stick B. If it doesn't work, I just use the previous stick. And and ensuring that stuff has not been modified is something like SHA-to-word list if you really want. Again, it's not really the same thing about like using a TPM, but you get some of the general ideas. So I think I've convinced you that live distros are cool. You already knew that Debian is the best, so I didn't have to say this. We have some ARM64 image finally available, which is great. And yeah, and it's very easy to create your own images if you want to. That's it.
Do we have any questions?
Hey.
Hi. Well, what I forgot in my talk, which is probably a good question here in this house, is in what hardware can I inject your live image for ARM laptops? I'm seeking an ARM64 device where I can put either your live image or
Right.
Debian installer and
Yes.
be done.
It's a good question. So for some machines, like the ThinkPad X13S, you can use Debian Live, but there are a few kernel modules that are needed for the machine to boot, which are not in the default initrd. So you would have to create your own custom image. It's simple. I've done it, so you could use that. On the system that Steve has, you don't need to do anything. You can just use the default ISO. He actually did. He booted the ISO that we've built, and it worked, which was very good to see. So the answer is it depends.
I would love to have an ARM laptop which just behaves like you describe. I would buy it.
Yes, we all do.
The questions you almost had just there. PCs are different. One of the things that almost every machine has is you've got different drivers, different bits and pieces under the hood. How does a live image cope at boot time with all of these different complicated bits of hardware? Can it, one of the big ones I see is the ability to have a speech installer, for example,
Right.
while you're booting. How does it cope with different GPUs and bits and pieces as a machine is coming up to start with? So what's there to support that?
Roland, yeah, go ahead.
So, as hinted, I am one of the active maintainers for live images. The answer is solved by Debian. It's called non-free firmware. That is activated and it works and it finds all your silly devices that aren't supported in free firmware, of course, additionally, and that's available. If you want to, you can turn it off, of course.
Also, a large initrd is partially the answer, which means, again, if you want to save space because you want to build a very small image and you know which hardware you have, then you can be a bit more surgical and choose only the modules you need.
Is the live image accessible?
This is a very good question. I haven't done any testing in that regard.
Yes, it installs GNOME. If you have the GNOME image, you get the Orca reader, etc. And if you do the installer that is included in the image, you also have the high contrast version, speech version, so all the installer variants are present.
Well, trying to produce init ramps which would support a number of different machines, I found that I rapidly hit the init ramps size limit for the buggy version of Grub, which has been around for years, so it wouldn't decompress. Any comments on that?
No.
We use apparently a newer version because we test it all the time and it just works with the current versions of Grub, etc. Then I had some few additions or short questions. On slide 27, sorry, details. Yes, so nowadays we can also use snapshot.debian.org to have a fully reproducible build. So I think I shall write some mail to Ayana and tell them, well, I know how to do it, I can show you.
Yeah, that would be a good idea.
And that would be nice because I use a similar system for that to generate the Debian live images. They are reproducible. You can do that every time bit for bit identical nowadays, starting with Bookworm 12.7. And then slide 9.
Does this work? Wow, almost.
Yes, so there's one change pending. The LB config, you can't do that soon without specifying your version of Debian that you want. So you need to specify, do I want to have SID, Forky, Trixie, Forky not yet, but soon, Trixie, Bookworm, Bullseye, that works soon. And it will be mandatory.
So talking about the ARM64 live images, we're already talking to DSA about getting an ARM64 server, so we will be able to build more than one ARM64 live image on release day instead of taking an entire week. We'll get there.
Nice.
I think we're done. Thank you very much, Emma.
Thank you.